Let's look at another exam question. In the diagram, EO bisects AC in triangle ACE. EO bisects AC in triangle ACE. That's what we are told. EDO is produced to be such that BO is equals to OD, such that BO is equals to OD. AD and CD are produced meet EC, and EA at G and F respectively. They are produced, they meet EC and GA at G and F. So this is produced, AD is produced, it meets this at G, and CD is produced, it meets AE at F. Now, they say to us, A, give a reason why ABCD is a parallelogram. Why ABCD is a parallelogram. Therefore, ABCD is a parallelogram because diagonals bisect each other. You can see that AD bisects AC. Therefore, this is equals to that, and also OA is equals to OC. OB is equals to OD. Also, OC is equals to OA. Therefore, this is a parallelogram because diagonals bisect each other. Since diagonals bisect each other, it means that this is a parallelogram. B, they say write down with reasons 2 ratio equals to ED over BD. Write down with reasons 2 ratios that are equals to ED over DB. ED over DB. Now, obviously here we are going to use theorem number 1, where we can see that DG in this triangle EBC, DG in this triangle BCE is parallel to BC. This side is parallel to this side in this triangle. Since this is parallel to that, because we know a parallelogram, opposite sides are parallel. Therefore, it means that this side is parallel to this side. Therefore, it means that DG is parallel to BC in triangle BCE or triangle EBC. Now, ED over DB is equals to this over that. This line is drawn parallel to that, and it divides the other two sides in the same ratio. Therefore, this over that is equals to this over that. So, which is equals to EG over GC. Since ED over DB, obviously this side is parallel to that, it is going to be equals to EG over GC. Reason for this, it is because DG or line drawn parallel to one side of a triangle. Line drawn parallel one side of triangle. That is why these two are equal. They said B, write down with reasons two ratios, each equals to ED over DB. Now, in this triangle, which is ABE, in triangle ABE, we can see that this line is parallel to that. We know that this is a parallelogram. Opposite sides are parallel. Therefore, this side is parallel to that side. Therefore, it means that DF is parallel to AB in triangle EAB. In this triangle, we know that this side is parallel to that side. Therefore, in this triangle, it means that DF is parallel to AB. Since DF is parallel to AB, then we know that ED over DB is equals to EF over FA. There's another one. ED over DB is equals to EF over FA. Reason also here I should have said line to show which line is drawn parallel. Line DG is drawn parallel one side of triangle. I can even say which triangle is that. Triangle EBC. Triangle EBC. Even here, line DF, line DF is drawn parallel one side of triangle. Which triangle is that? EAB. Triangle EAB. Therefore, this over this, this over that is equals to this over that. Also, this over that is equals to this over that. These are the two ratios with reasons which are equals to ED over BD. Now, C, they say to us, we must prove that angle A1 is equals to angle F2. They want us to prove that this angle here, angle A1, is equals to this angle there, which is F2. And for us to prove that, obviously, we know that this is a parallelogram and opposite sides are parallel, and we have a Z shape there. Therefore, it means that this angle is equals to that angle there. I can even highlight it there. We know interior alternate angles since AB is parallel to CD. We start there. This is C. This is B. Now C, we are proving that. Therefore, we're going to say angle A1 is equals to angle C2. Reason, interior, alternate angles. Why are they alternating? It is because AB is parallel to CD. Now, we know that this angle is equals to that angle. But now, we know that ED over BD is equals to EG over GC. Also, ED, which is ED over BD, is also equals to EF over FA. Therefore, not ED, sorry, EG. Therefore, these two are equal, since they both equals to that. So, EG over GC is equals to EF over FA. Let's look at that. Since this over that is equals to this over that, which is also equals to this over that, it means that this over that is equals to this over that. That's what it means. Proved. Or both equals to ED over DB. Or we could have said the reason proved, because we proved it on B, proved on B. But we just say these are equal because these are equal because they both equals to the same ratio. Now, since this over that is equals to this over that, it means that this side is parallel to this side. It means that, therefore, GF is parallel to AC. Reason, line divides sides, line or segment divides, or div, segment divides, lines divides sides in proportionally. Line divide sides proportionally. Since this line divides this side and this side in the same ratio, then it means that this is is parallel to that. And since this is parallel to that, then we know that, therefore, we have a Z shape, because these two sides are parallel, since this line divides sides proportionally. Because we said that EG over GC is equals to EF over FA. They are both equals to ED over DB. Therefore, these two sides are parallel. Since these two sides are parallel, it means that this side is going to divide this side and this side in the same ratio. Therefore, it means that these two are parallel. Since these two are parallel, we've got a Z shape. Therefore, this angle is equals to that angle. Therefore, angle C2 is equals to angle F2. Interior alternate angles are equal. That's why we're saying that. Now, we know that A1 is equals to angle C2 and angle C2 is equal to angle F1. Therefore, angle A1 is equals to angle F2. Why? Both equals to angle C2. Therefore, we have proved that angle A1 is equals to angle F2. Now, D, it is further given that ABCD is a rhombus. It is further given that this is a rhombus. Then they say prove that ACGF, prove that ACGF is a cyclic quadrilateral. I'm going to remove here because I've already done that, and even here for me to prove that ACGF is a cyclic quad. Now, D. For me to prove that this is a cyclic quad, I know that this angle here is equals to this angle there. Now, angle A1 is equals to angle A2. Why is that? It is because since this is a rhombus, diagonal bisects the vertex angles. Since it is a rhombus, this is equals to that. This diagonal bisects this angle. It bisects also this angle. This diagonal bisects this angle into two equal angles. Therefore, it means that this angle is equals to that angle. Therefore, it means that also this angle is equals to that angle. It also means that this angle is equals to that angle. Also, this angle is equals to that angle there. That is why we say angle A1 is equals to angle A2. Reason why we're saying that, it is diagonals of rhombus. Diagonal of rhombus, obviously they bisect the vertex angles. Now, we have seen that this angle is equals to that angle just now, but we know that this angle is equals to that angle there. Therefore, we know that A1 is equals to angle F2. Proved. We've proved it, that angle A1 is equals to F2. Now, angle A2, therefore, angle A2 is equals to angle F2, right? Angle this is equals to that. Reason for that, they both equals to A1. They both equals to A1. You can see that. Both equals to angle A1. Therefore, ACGF, therefore ACGF is a cyclic quadrilateral. Why is it a cyclic quadrilateral? Reason is that angles at the same segment, angles at the same segment are equal. Since angles at the same segment are equal, it means that this is a cyclic quadrilateral. It means that I can have an imaginary circle that passes through those points there to make this a cyclic quad, showing that these two are angles at the same segment which are subtended by the same chord or by the same arc. Therefore, ACGE is a cyclic.